So we learned how to calculate the linear regression line. And as you saw, here you have 0.9, which is a very strong positive linear correlation. It means that the line is increasing. So the graph behaves like this. And as we did the calculation, the slope of the line is also positive. So it means that you have an increasing line. The regression line, after verifying that the linear correlation between two variables is significant, the next step is to determine the equation of the line that best models the data. This line is called regression line, and its equation can be used to predict the value of y for a given value of x. Although many lines can be drawn through a set of points, a regression line is determined by specific criteria. Consider the scatter plot and the line shown below. For each data point, d sub I represents the difference between the observed y value and the predicted y value for a given x value. These differences are called residuals and can be positive, negative, or zero. When the point is above the line, d sub I is positive. So here, above the line, d sub i's are positive. The difference between the predicted value and the observed value is positive. But if it's below the line, the predicted value minus the actual value is going to be negative. So the residuals are positive or negative. When the observed y value equal to the predicted y value, the residual is equal to 0. There is no difference. There is no error. Of all possible lines that can be drawn through a set of points, the regression line is the line for which the sum of the squares of all residuals is minimal. This is what we use in machine learning. We try to minimize the error. So we don't like to have too many residuals. We would like to have the predicted values and the observed values have minimum difference. That's why we're interested in having this number sigma di squared to be in minimum form. Regression line, also called a line of best fit, is the line for which the sum of the squares of the residuals is minimum. So our goal in machine learning, in deep learning, is to find the best regression line, and then we, of course, change the idea and generalize the idea to more advanced algorithms. In algebra, you learn that you can write an equation of a line by feeding its slope m and y-intercept b. The equation has the form y equals to mx plus b. Recall that the slope of a line is the ratio of its rise over its run. Rise over run. This is slope or rate of change. Okay, as you can see, here we have the regression line with residuals. Now we're going to show you how to actually find this best line. So it's the y value when x is equal to 0. For instance, the graph of y equals to 2x plus 1 is shown in the figure at the right. The slope of the line in this case, the rise over run, is 2 over 1 or 2. The y-intercept is 1. As you can see, the line is an increasing line. In algebra, you just use 2 points to write the equation of the line. However, when it comes to statistics, we have more points to work with. The equation of regression line. The equation of regression line for an independent variable x and a dependent variable y is defined as y hat. So you have y hat equals to mx plus b, where y hat is the predicted y value for a given x value, slope m, and the y-intercept b are given by m equals to n times the summation of xy minus summation of x, summation of y, divided by n times summation of x squared minus summation of x to the second power, and b, or y-intercept, is y bar minus mx bar, which is sigma y divided by n minus m times sigma of x divided by n. Y bar is the mean of the y values in the data set, and x bar is the mean of the data values x values, and n is the number of pairs of the data. Then the regression line always passes through this point x bar and y bar.